We want to determine the interval or intervals on which f of x equals 1/2 x to the fourth minus 9x squared is increasing. Well, the function will be increasing when the first derivative is positive. So first let's find the first derivative. So what is f prime of x? Well, that's going to be 1/2 times 4x cubed minus 18x, which is 2x cubed minus 18x. And since we're going to want to know when that is positive and negative, let's find out first where that is equal to 0. So let's go ahead and factor this. We can take out a 2x, and that gives us x squared minus 9. And then we can factor it further. We have 2x times x minus 3 and x plus 3. So we have three values of x, 0, 3, and negative 3, where the first derivative equals 0, and then we're going to do test points on either side to see what is the sign of the first derivative. So I usually make a table here, and in the top row I'm going to put the values of x that make the derivative equal to 0. So since negative 3 is the smallest, I would put negative 3 there, and I'm going to do that in pink. I'm going to put then 0, and then to the right of that I will put 3. And notice I left space to the left of negative 3 so that I can test values that are smaller than negative 3, and we have space that is to the right of 3 so that we can test values that are larger than 3. Now let's put our first derivative here in its factored form. So 2x times x minus 3 times x plus 3. Now at these values, negative 3, 0, and 3, our first derivative equals 0. So we'll put zeros there. Now let's pick a value of x that's less than negative 3. Let's say negative 10. And we don't really even have to calculate the number to put it when we put it into the first derivative. We just need to know the sign. So if x is negative 10, then 2x is going to be negative. So that'll be negative. If x is negative 10, then x minus 3 will also be negative. So we'll have a negative times a negative. And if x is negative 10, x plus 3 will still be negative. So we'll have a negative times a negative times a negative, which is going to be negative. So the first derivative, the sign of the first derivative, is negative on that interval. Now what about between negative 3 and 0? Well, let's test negative 1. So when we put in negative 1, 2 times negative 1 will be negative. Negative 1 minus 3, that'll be negative. But now negative 1 plus 3, that's going to be positive. So we're going to have a negative times a positive, which will be positive. So our first derivative will be positive between negative 3 and 0. What about between 0 and 3? Well, choose a value, let's say x equal to 1. So now 2 times 1 will be positive. X minus 3, if x equals 1, that will be negative. And x plus 3, well, that will be positive. So we'll have a positive times a positive, which will be negative. So our first derivative is negative on the interval between 0 and 3. And finally, let's pick a test value larger than 3, like, I don't know, 10. So if we have x equal to 10, 2 times x will be positive. 10 minus 3, well, that will also be positive. And then 10 plus 3, that will also be positive. So we'll have a positive times a positive times a positive, which is positive. And now we just have to look at the intervals where the first derivative is positive, because that's where our function will be increasing. So it's positive here, and it's positive here. So it's positive on the interval between negative 3 and 0, and anything larger than 3. So that would be from negative 3 to 0, and from 3 to infinity. So we would choose answer C.